Welcome to video number 54 in the Using iTrain tutorial series. My name is Bob. In this tutorial we create an AND-based action using the rules defined in the last tutorial, and we use animations to explain the operation of the action. Welcome back. In the last tutorial we discussed the basic operation of the AND operator and defined two rules for creating an AND-based condition. Rule 1 said an AND group must contain at least one state plus one and only one trigger. From this table we can see that the only elements that can provide a state are the ones that we have called dual mode. So if you preferred, you could replace the word state with the word or phrase dual mode. An AND group must contain at least one dual mode plus one and only one element that will be used as the trigger. That trigger can either be another dual mode element which will automatically act as the trigger, or it can be a single trigger only element. Rule number 2 says if an AND group contains a trigger only element, that element needs to be the last condition activated in the sequence of events on the physical railway. So rule number 2 would only apply if we have used a trigger only element as the trigger in rule number 1. If we're just using dual mode elements in rule number 1, then this rule here would not apply. So let's put those rules into practice and create a simple AND-based action with two conditions. Here's a diagram of what we're going to create. Again, rule number 1 says an AND group must contain at least one state, and a state is only available from a dual mode element. In our example here, we will select a feedback as the dual mode element, and the state that we want to detect will be the on state. Rule 1 then says plus one and only one trigger. And we further clarified that that trigger can either be another dual mode element which automatically acts as the trigger, or it can be a single trigger only element. For this first example, we will use another dual mode element as the trigger, and we will also make it a feedback sensor, and again the state that we are trying to detect will be the on state. We don't have to do anything to make the dual mode element act as a trigger, as we will see later, iTrain inherently does that automatically due to the way that the tests operate. As soon as the action is made active, the tests will be continuously running and comparing the input signal from the condition element to its associated reference state. Now, you may have noticed that I've changed the look of this test compared to the OR action that we saw in a previous tutorial. The OR action has the same test setup as shown here. I have just added the reference input this time so that it is clearer that this test is a comparison test of these two inputs. It is continuously comparing the event or state coming from the condition element, which in this case is a feedback sensor, and comparing it to the reference state which we specify when we create the action. In this example, we are using the ON reference state. When the condition element event or state matches the reference state, the output of the test will go high, meaning that the test is true. When both inputs to the AND are true at the same time, the output of the AND will be true, the condition will be met, and that will trigger the execution of the action, which will be to play the Welcome to iTrain sound file. Now, because we're not using a trigger only element in this example, we can ignore rule number 2. Creating an AND-based condition is the same process as the OR-based condition, except that we need to apply the rules. So we create it in the same way by opening the action editor and clicking New for a new action. We need to give it a name, which I will call AND dual plus dual. Then click Append to add the first item. The operator is automatically selected first, and this time we need to have the AND operator selected. And below the AND we will list the conditions that we want to be included in this AND group. So we click Append, and then note that we get this tie bar being added here, which indicates that the items that will be listed below are part of this AND group. We want this to be a feedback sensor, so we select the feedback. We can go down to the list of feedbacks and we will select which one, Northwest, I think. So Northwest has been added as the feedback sensor, and the reference state that we want to test for is the ON state. So now we can click append again to add our second condition in this group. We want it to be a feedback, but this time a different feedback, and I'm going to pick self-siding, and again its reference state will be the on state. So that's our two conditions set up. And notice we haven't had to do anything to say that this one or this one will be the trigger or the state. iTrain will automatically select the appropriate conditions or states or triggers that it needs to use to operate as an AND. So when both of these conditions are true at the same time, that will then execute the commands listed in the execution tab. And to add our command, we simply click append, and for this execution we want it to play the Welcome to iTrain sound file. So we select sound from the list, and then down here we can actually set the welcome file, and we want it to play. So that is our AND based condition or action completed. As soon as we select apply, we see that the action has appeared in the list here, and it is now active, as can be seen by the tick here. I previously disabled the OR group action that we created previously, so that when we test this one, we're not also activating this OR group action. So now we can close down the window. Those two conditions that we created are now running, so the tests are running, and comparing the feedback northwest against the on state and the feedback south-siding against the on state. Both of the feedbacks are off at the moment. If I turn on the northwest feedback, we don't hear the action being triggered at the moment, which is correct. But as soon as I click on south-siding,
welcome to iTrain,
then the action is triggered. And if I unclick this one and unclick that and repeat it the other way around,
welcome to iTrain,
you see the action triggers immediately that both feedbacks are on at the same time. So you can see that it doesn't matter which one is turned on first.
Welcome to iTrain.
But as soon as they are both turned on, then
welcome to iTrain,
the action triggers. Let's have a look at the animation to see how it operates. This isn't an accurate replica of how iTrain works. It's a simplified analogy that allows us to better follow and understand the operation. Here we are showing two inputs from the feedback sensors, with the waveforms representing their states on the vertical axis, so off and on, versus time on the horizontal axis. Time is travelling in this direction, like this. So this event would be seen first, followed by this event. And here we have the reference states which we defined when we created the action. The outputs from the feedback sensors are detected by the condition and continuously compared to the reference states. At some point in time, one of the feedback sensors will turn on, as denoted by the dashed orange line shown here. If we take a snapshot at this precise moment in time, we can see what the tests are detecting at that precise moment. Here, the state has changed from off to on, so the input state matches the reference state, and consequently the output of the test goes high, meaning that the test is true. For the other condition, at the same precise moment in time, the state of the other feedback is still off, so its state does not match the reference state at that precise moment in time. So the output of the test is low, meaning that the test is false. A true and a false on the input to the AND group means that the output of the AND will be false. The condition is therefore not met, and the action will therefore not be executed, and no sound will be produced. Now, later in time, perhaps a fraction of a second, or maybe several seconds later, the other feedback also turns on. Its state now matches the reference state, so the output of the test therefore goes high, meaning that that test is now also true. The state on the other input condition has not changed. It is still true. So now both inputs are true at the same time. The output of the AND therefore becomes true. The condition is now met, which executes the commands in the execution tab, and that then plays the sound file. So in effect, the event that occurred when the last feedback sensor turned on has triggered the chain of operations that ends with the sound file playing. This feedback sensor, which caused the last event in the sequence of events that occurred on the physical layout, has effectively and automatically acted as the trigger. We did not need to do anything to make it act as the trigger. That occurs inherently due to the way that the system operates. A feedback sensor is a dual mode element, so iTrain can use it as an event or as a state. We could say that when this final event occurred, this test was using the state of the feedback sensor, and this test was using the event of the feedback sensor and thus acting as the trigger. Now, what happens if this feedback sensor changes state before the other feedback sensor? Does the action still operate in the same way? Well, let's have a look. This feedback sensor is going to turn on first. The output of its test will go high, meaning that the test is true. On the other feedback sensor, its state at that precise time is still in the off position. So its state does not match the reference state, therefore the output of the test is low, meaning that the test is false. Later in time, this feedback sensor will then turn on. Its test therefore goes high, indicating that that test is also true. The other feedback is still in its on state, so is true. So now we have a true on both of the inputs at the same time to the AND group. Therefore, the output of the AND becomes true, the condition is met, and the execution of the commands goes ahead and the sound file plays. So this time, this feedback sensor was used as a state, and this feedback sensor was used as the trigger, which triggered the chain of events which ended in the sound file being played. So iTrain inherently chooses or uses these inputs depending on which it receives last. We haven't had to do anything to determine whether this feedback or this feedback was being used as a state or a trigger. It inherently goes on due to the way that this circuit operates. The important thing from iTrain's point of view is that it is able to use this event or trigger to maintain control of when these operations are happening, and therefore it can keep control of all the other things it is trying to do within iTrain. So it appears that the order in which these dual mode elements occur does not affect the operation of the action. But unfortunately, that isn't always the case. And that is the subject of the next tutorial, where we will further divide the condition element types into two subcategories, which we will call static and dynamic. So we have dual mode and trigger only elements, and then we will further divide those into two subcategories called static and dynamic. Now, you will not find those four terms used in the user manual, at least not in the same context. So don't bother trying to look them up. They are simply terms that I have used in these tutorials to make it easier to describe and correctly construct actions. Static elements are the feedback sensors, relays, and aspect signs. All the rest of the condition types I am classifying as dynamic, including all the trigger-only elements. Static elements are happy to stay in the state that they are currently in. Their states remain stable or static. Dynamic elements have only one stable state, which is usually its default state, and any other states are often only momentary. They have a tendency to try to revert back to their default states. So their states can be more dynamic or moving or unstable in their operation. Perhaps not always, but often enough that we need to be more careful about how and when dynamic elements occur in the sequence of events. Now, these are not strict categories. For example, we could argue that some of the dynamic elements are static elements. However, for the purposes of these tutorials, that is how we will classify them, because it will make it easier to construct actions that work consistently. So what is the importance of static and dynamic elements? Well, for AND operations, static elements can be used in any order in the sequence of events that occur on the physical layout, and that order will not affect the outcome of the action, which we saw demonstrated earlier in this tutorial. But with dynamic elements, we need to be a little more careful about when and where they occur in the sequence of events. Otherwise, the action may never execute, or at best will be inconsistent in its operation. So, as I have said, we will cover this subject in the next tutorial. But in the meantime, for some practice and to prepare yourself a little better before the next tutorial, I've created various different scenarios. Your mission, should you wish to accept it, is to identify which of these scenarios will trigger the execution of the action and which will not. This is scenario 1. Your task is to look at this setup and the waveforms that are coming into the condition and try and work out if the action will actually be executed when these waveforms come into the tests. Imagine you've got the timeline that is running across the waveforms. At any point are the states such that we will get true and true on the input to the AND gate, which will cause the condition to be met and the commands to be executed. So this is scenario 1. Will the sound be executed? This is scenario 2. Again, will the sound be executed? This is scenario 3. This is scenario 4. This is scenario 5, and this time we're using a trigger only event. Will the sound be executed? Here is scenario 6. Here is scenario 7. And here is scenario 8. Pause the video on each one. Look at the waveforms and the settings. If you can, see if you can convert those waveforms into the outputs that will come out of the tests, like we did in the earlier animations, and see whether these will be true or false, and whether this will be true and false, and therefore whether this will be executed. With a bit of practice, you'll then just have to look at the waveforms and the settings here, and you will immediately know whether this will execute or not. Put your answers in the comments below. As usual, please, if you've learnt something today or like what you have seen, take a moment now to click on the like button. Only around 10% of viewers click the button. It costs you nothing, but it gives me some very valuable feedback. Thanks for watching. Hope to see you in the next tutorial.